check. बोल दे.
Check, check, check.
Check. बोल दे.
Check, check, check.
आ रही है. और मेरे को ये आई थिंक आई थिंक वी शुड बी गुड. एक और बार बोलना है. टेस्ट.
Test, test, test. Oh my god.
Okay. We can get started now. देख रही है ना मेरी स्क्रीन? All righty, tighty. So, this is day 29 of doing Learn OpenUSD. Not Learn OpenUSD, but overall physical AI study and simulations. And this is the fourth module that we are trying to complete now in the Learn OpenUSD modules for the OpenUSD certification by NVIDIA. And we have completed the first three, which are setting the stage, scene description blueprints, composition basics. And today we are going to be beginning and potentially not completing, but you know, uh, covering a lot of beyond the basics module. So yeah, let's get started.
Beyond the basics. In this module, we will go deeper into the production ready techniques that power real world pipelines involving complex scenes, data workflows, and custom requirements across the industries and use cases. What we will learn by the end of this module is work with primewares.
Primvars.
Oh my bad. Primware. A primware primitive variable is a specific kind of attribute that can vary and interpolate across a geometric primitive. Attach rendering data like UVs, vertex colors, and custom attributes to geometry. Leverage value resolution. Understand how USD resolves attribute values from multiple composition sources. Third is create custom properties. Extend the USD's data model with user defined attribute for specific workflows. Manage scene complexity. Use active inactive prems for efficient and non destructive scene management. Utilize model kind structure asset using component assembly and group hierarchies. Travel stages. Implement high performance iteration through complex scene graphs. Understand Hydra rendering and work with USD's flexible rendering architecture and multiple backends. Handle units in USD, work with meters per unit, up axis, time code per second, and understand automatic versus manual unit reconciliation during composition. So all in all, we are gonna learn a lot more about like basically beyond the basics. We have primvares and looking at the different kinds of units and everything else over here. Now, why these skills matter? Wait,
Okay,
let me
wait.
start.
So I think I understand a lot of this stuff. Primvars is obviously new, but leverage value resolution understand how a USD resolves attribute values from multiple composition sources. So I think this is where the variant sets will come in play, where we basically, you know, have different variant sets with high resolution, which is high level of detail, or low resolution or low level of detail. So I think that's where this variant set part will come in play. What is this? Value resolution is the process of determining the final composed value of a property of a yeah, exactly. Then creating custom properties. Properties are namespace objects that contain the actual data in USD. Namespace objects. Namespace objects that contain the actual data in USD. Extend USD's data model and user-defined attribute for workflows. That is something new. I don't know. Manage scene complexity. Use active and active prims. Active is metadata. The active metadata provides way to temporarily remove a prim and its children from your scene without actually deleting them. Oh, okay. So basically, like doing like a toggle of turn on or off for a prim in a scene to basically remove it or add it without being non-destructive to the scene management.
Mm-hmm.
And then utilizing model kinds, models partition large scene graphs into manageable pieces by annotating prims with kind metadata. So okay, and then kind is metadata that classifies prim into categories or for organizational and traversal purposes. Okay. So structure assets using component assembly and group hierarchies. Okay, so this is something new. I don't understand what this is. Um, Traverse stages implement high performance iteration through complex scene graphs. So I think traversals are basically what we were doing yesterday. Uh,
Mm, yep.
yeah. Traverse, basically what we were doing yesterday, you know, for the composition engine, the first traversal can be, just to capture defined prims, which are def, and
Mm-hmm.
then later in the later iterations of the traversal, the over and class would be captured in the composition engine for it to be rendered in the scene, and then understand Hydra rendering. So now we are going to be working with USD's flexible rendering architecture and multiple backends. So understand Hydra is USD's high performance rendering architecture that provides an abstraction layer between scene data and renderers. So Hydra is USD's high performance rendering architecture. Okay, I thought it was like a rendering software.
More new findings. I think
Mm.
Hydra rendering is something else, and Hydra is something else maybe. Hydra is uses high performance rendering architecture that provides an abstraction layer between scene data and renderers. I see. I see.
Oh,
All right.
renderer. Yeah, I thought Hydra was a renderer itself, but it is not a renderer. It is an architecture that provides our abstraction layer. Mm. Okay, and then handle units in USD work with meters per unit, up axis time codes per second. I understand automatic versus manual unit reconciliation during composition. Mhm. So this is some sort of metrics
Why
in
the real
USD. Yeah.
math? These advanced techniques separate hobby projects from production pipelines. They are tools that enable performance at scale, handle scenes with millions of frames through efficient traversal and selective activation, pipeline flexibility, extend USD with custom data that fits your specific workflow needs, asset organization, structure complex projects with clear hierarchies, and scale across teams, rendering integration, connect USD scenes to any rendering backend through Hydra's extensible architecture, production robustness, build reliable systems that handle edge cases and complex data resolution scenarios.
Mm-hmm.
Hmm. So what we can do is performance, pipeline flexibility, asset organization, And rendering integration. Oh, pretty cool.
So pipeline flexibility is extend USD with custom data that fits your specific workflow needs. Asset organization, structure complex projects. What is asset? Okay, yeah. Rendering integrations connect USD scenes to any rendering backend through Hydra's extensible architecture. Production robustness, build reliable systems that handle edge cases and complex data resolution scenarios. These skills prepare you for the most advanced USD topics, creating custom schemas. A schema is an object that provides structured API. Yeah, exactly. Now they are coming on schemas.
Dude, they were
Uh,
already, but they are like recollecting everything what we have done till now.
yeah. Schema is an
Reconcile.
object that provides structured API for authoring and retrieving data from prims and or properties. Building specialized tools and architecting large-scale USD-based systems, which we'll cover in intermediate learn OpenUSD modules. So even this is intermediate. Then what is advanced?
Only one way to figure out. Attack. Next.
Primwares video. Are you able to hear?
Primvars, short for primitive variables, are special attributes that contain extra features. They address the following problems in computer graphics. First, the need to bind user data on geometric primitives that becomes available to shaders during
Wait, I
rendering,
missed the
like
first part.
storing
Why?
UV
One second.
primvars. We'll explore our series on OpenUSD. In this lesson, we'll explore primvars. Understanding primvars enables efficient management and manipulation of hierarchical object data in complex 3D scenes. Primvars, short for primitive variables, are special attributes that contain extra features. They address the following problems in computer graphics. First, the need to bind user data on geometric primitives that becomes available to shaders during rendering, like storing UVs for texture mapping. Second, the need to specify a set of values associated with vertices or faces of a primitive that will interpolate across the primitive surface under subdivision or shading, like defining vertex colors for per-vertex shading. And finally, the need to inherit attributes down namespace to allow sparse authoring of shareable data, while still allowing overrides by the child prims. Some examples include texture coordinates, vertex colors, or custom metadata, allowing for interpolating data on individual objects. Primvars are defined within the scene description and can be accessed and modified using OpenUSD APIs. Each
APIs.
primvar can store different types of data, such as scalar values, vectors, or arrays. Developers working with OpenUSD can interact with primvars using the Python API. We'll first import the USD Geom, SDF, and GF modules, then construct a USD Geom primvars API on a prim. Then we'll create a new primvar called displayColor of type color 3 float array.
Short
Get the
for
displayColor
primitive
primvar.
variables.
And this is how we can
Primvar
set
is
and
a
get the
special kind of
display color
attribute that
values.
can vary and
The ability to
interpolate
store
across
and
a geometric.
रुक तो जा 1 second. Let it
Oh,
complete.
manipulate
oh, my video
hierarchical
was
object
completed.
data
I
using
removed
primvars
like I.
is a powerful feature that enables advanced 3D workflows and facilitates interoperability between different tools and applications. Thanks for watching. Check out the following resources and
Okay.
we'll see you in the next.
Okay. Short for primitive variables. Primvars, a special kind of attribute that can vary and interpolate across geometric primitive. Very complicated wording, but okay. So, short for primitive variables, primvars are special attributes that contain extra features. They address the following problems in computer graphics. Um, the need to bind user data on geometric primitive, bind user data that becomes available to shaders during rendering, the need to specify a set of values associated with vertices or faces of a primitive that will interpolate across primitive surface under the subdivision or shading. Bro, I am not able to understand a single
But
word over here.
we should keep going on and just look at the code base we have, and then we will understand everything.
The need to inherit attributes down namespace to allow sparse authoring of shareable data. Some examples include texture, coordinates, vertex colors, or custom metadata, allowing for interpolating data on individual objects. Primvars are essential for various tasks, storing UVs. What are UVs?
Ultraviolet,
Oh, fuck, no, I don't think that's you.
unique
UV,
vehicles, utility van or something.
bro. Sto- Storing UV.
Utility something for sure.
Texture coordinates,
What the hell is UV
horizontal
refers
axis and vertical. Yeah, ultraviolet.
ultraviolet utility some. But how is it? Or U
Bro,
is
X, Y,
U.
and Z are axes. Describe 3D axis of physical world, width, height, depth. Computer graphics uses U and V to talk about 2D axis of a flat image. Bruh, this is not new.
No
It's
worries, brother. We
it's
will learn. I
getting
will go through. We have dude. This prim notebook, like this whole module is really big. Yeah, dude, it is really big.
bro.
We're gonna get to know more about each and every freaking thing that we're learning right now, and that's how they designed it. Like they're opening their cards slowly. They're opening their cards slowly.
पत्ते धीरे खुलेंगे.
लेवल सबके निकलेंगे.
Okay, storing UV for texture mapping, defining vertex colors for per vertex shading, deformation and animation. Okay, so primvars are essential for various tasks. How does it work? Primvars are defined within the scene description and can be accessed and modified using OpenUSD APIs. Defined within the scene description can be accessed modifying OpenUSD APIs, correct? Each primvar can store different types of data, such as scalar values, vectors, or arrays. Refer to the primvar user guide. What is this? Primvar is a special type of attribute that can interpolate. Blah blah blah. Oh, okay. I think
Mesh constant. Oh, primware. Oh.
Hydra metal camera free flow. Okay, you can further control the elements interpolated for subdivision surfaces. Hmm. Okay, let's go back. Refer to the primvar user guide to learn more about how primvars work, including concepts like the different interpolation modes supported by primvars, index primvars, and primvar inheritance. I see. Okay.
Primware API. That is the most important thing, first of all, to
Mhm.
initiate primware's API. And then once we have initiated the prim vars API, we can create prim var and then assign a new var called display color. Then we have sdf.valuetype.color 3f array. This is something new API.
Wait, construct a USD geom prim vars API on USD prim prim. What does that mean? USD prim prim on?
Dude, you need to construct on a prim, right? You cannot create a construct on like that prim var on any other stage or something like that. So a prim, to create a prim var, you need a prim.
Yeah,
So that's what it is saying over there. Construct a geom USD
USD.
geom yeah on USD prim. USD prim is the library that we import USD, USD prim.
Mm-hmm.
So we have already imported a prim library somewhere, and then we are basically assigning the prim vars API and
Uh-huh.
including that prim or wrapping that prim into that API.
Mm-hmm. Okay. And then create so primvar underscore API USD geom dot primvars API prim. I think there's like a typo or something over here.
What kind of typo are you looking
Why
for?
is there a dot between USD geom and primvars?
Dude, how are you gonna call the function?
USD geom is a function itself. Is that
USD
what?
geom is a library, and
Library
then
and primvars API is the function.
yeah,
And then we are passing prim as a parameter in that function
yeah, basically you're wrapping the prim so
to
that you
create
can.
a primvar API.
Yeah.
Oh, now I get it. Construct a USD geom primvars API on USD prim prim. I get it now. Okay, create a new primvar called display color of type color 3f. So primvar API dot create primvar. Okay, this is the function and this is the API thing and this is the function.
Dude,
Uh,
look at this. NASA is building a moon base.
Wait, let me increase your size.
Are you able to focus?
What is this moon base? This will be awesome. Okay, I
That's
see.
Elon Musk.
We're building moon base, will serve habitat. Astronauts will live and work during long-term science missions. Oh, I want to go there, bro.
For sure, one day we one day Elon Musk will take us.
Elon,
Elon brother,
hello.
Elon Musk. Let's tag him. Please book 2 tickets.
Two
Reserve 2 tickets.
tickets for
Reserved
moon.
for moon. All right, let's get
Moon, we'll do moon rocks on moon.
there. Bring back.
Out of this world. Okay, primvar API, we are using create primvar function to create a new primvar called display color of type color 3f. So display color sdf.value type name dot color 3f array. What does this mean exactly?
Dude, that is basically we are creating what is on the line 11.
Hmm.
So what we are trying to do is we are assigning some kind of attributical value that we can assign it to later. So I think what we did over here is created. Do you remember lambda functions? How lambda
Yeah.
functions?
Yeah.
We did a similar kind of thing, but in a more advanced way. So first we created
Yeah.
a prim, and then we assigned the prim with a display color name
Mm-hmm.
and a type that like what is the functionality or what would that prim do, the
Mm-hmm.
custom prim. And once we did that, we tried to set the values to it since we knew that okay we already have the color 3f array onto that. So we went to line 11 and we said prim var dot set whatever the value we wanted into that array, and voila, we have the values set over there. And that's what this example is showing us, how we can create custom prims by naming them and assigning them a certain type of value. that can be reused later on, or
Mm-hmm.
maybe later on.
I see.
Yeah.
Primvar equals to primvar API dot get primvar, get the display color primvar, sets the display color values, primvar dot set gf vec3f o10, get display color values equal to primvar dot get. Okay, let's see at look at the examples. We have the notebooks over here, primvars. Okay, you can run these examples locally in the blah 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 blah. Yeah. Okay. Example one, primvar interpolation, constant uniform vertex. This example builds the same two quad mesh three times, two quad mesh three times, and authors a display color primvar with three. What the hell? Display color primvar with three interpolation determines how values are calculated between discrete and authored data points and carry distinct meanings for temporal data and geometric attribution. So primvars with three interpolation modes, constant, one value for the whole G prim, uniform, one per face, and vertex, one per point. Hmm, bro,
What?
look at the code now.
Code shit, man. Code. All
Uh,
right. We created a
create
file.
file stage, world
We
stage.
blah blah blah. We
Okay, this
define
is this is basic. We can ignore that.
we then from line 9 to line 17. That's a complex shit. But I think that's an
Two quad
array.
mesh topology.
Yeah. I think what does it render first? Like one, two quad. So what is quad means four,
Six
6 points.
points, two faces.
One, two, three, four. Wait, bullshit.
Face
Okay.
vertex
I'm
counts.
just I'm just gonna keep that over there, and I'm just gonna focus on first what are we doing in the highlighted point over here?
Define
So
interpolation mode and colors. Example meshes per prim. Interpolation USD geom dot tokens constant.
this is something an internal library, and then we have color per
Okay, so this
face.
is
We have per face, per prim, and per vertex. Oh, okay. Define inter.
so for
Oh,
I example mesh color details in I comma example mesh color details in enumerate example mesh dot items. In enumerate mesh prim equal to USD geom dot mesh dot define stage dot world dot get path. Okay, so this is basically defining the example mesh onto the world prim, um, and storing it in the mesh prim, and then we are creating point attribute on mesh prim, which is, I don't know what this is. Mesh vertex locks. What is this? Where did this come from? Oh, over here. Mesh vertex locks.
wait,
Okay.
what? Mesh,
Vertex
vertex. Oh, yeah.
defined over here.
Okay.
I think, bro, we need to understand this from.
No, wait. I know what it's doing. So we have example mesh and color details, and
Let
for
me
so
run it
example,
over.
where is color details defined? Let me take a look. Oh, mesh dot items. Oh, definitely. Okay, perfect. It makes sense now. Colors and then colors. Okay. So we have dot define dot get rule path append create point attribute create phase. Oh, bullshit. Translate mesh display color, dot display color, set interpretation, set this. Okay. Now what I'm trying to understand is we have mesh items. So what does item do? Item will give you two things. Per prim, and then okay. So if we iterate on the first one, we get per prim, and then we get interpolation and colors. So we have mesh defined dot mesh, that is interpolation, and then points is mesh vertex locks. Where is the mesh vertex locks coming from? Oh, over here. Oh, okay, okay. And then face vertex count, that is gonna be the same. Face vertex indices, that is gonna be the same. And okay, and we have common mesh prim. Okay, mesh prim. Wait, that translate. Oh, got it. I understood it completely. Got it. I
Look
got
at ChatGPT's response.
got it.
It's calling me Batman.
What?
I asked ChatGPT about the code.
Uh,
It's calling me Batman. This code creates.
we got the same too. Yeah, yeah. But I think we just need to first focus on like I did got what the for loop is doing, and we're trying to create the like iterate through each and every primware that we're trying to create. But what is this mesh vertex lock? That is the thing that we need to focus on because everything else is defined over there. So based on my understanding, what we did was apart from the variables that we defined, so first
Mm-hmm.
in the for loop we created our mesh and then defined it with the first example mesh, right? So based on that first example mesh, we
Mm-hmm.
have per frame, then per face, and then per vertex. So it will do three iterations, one
Mm-hmm.
and three, right? So since if we focus on the per frame, let's focus on the per frame and what is the values over there.
Mm-hmm.
So we have interpolation as USD dot tokens dot constant. This is something constant value that we already created. And then we
Mm-hmm.
have per frame color. So if we take a look at the per frame color, the values we have already decided, that is 0.5, 0.0, and zero point 0.5,
Mm-hmm.
right? That is clear. Now on the second line, we created mesh. We use mesh prim dot create point attribute to define our attributes for that grid.
Mm-hmm.
And that was already fixed based on the mesh vertex locks.
Mm-hmm.
And onto the third line, we created the face vertex counts attribute. That was already defined over here with face vertex count as 4, comma 4, and that rendered the other part. And then we have the indices. So indices would be the edges of that accordingly. So what was the index count? Indices count that was 0, 1, 2, 3, and 1, 4, 5, 2. That was rendered. And once we did that,
Where
we
are you
used
reading 0, 0, 1, 2? Oh, 1, 2, 3, comma 1, 4, 5, 2.
yeah.
But oh, I see.
Okay, like we need we will go on through those as well. But first, I'm trying to understand how did it rendered, and then we will go back to those variables. Okay, how
Bro,
what?
let's just read this fast. This is a explanation. Um, this code creates three copies of the same two quad mesh. Three copies of
Or
the two chord mesh.
two chord, but it says four or two. Yeah, two chord. My bad, two chord, two chord.
Two chord, bro. And then place them side by side and colors each one using different USD display color interpolation mode. So where's the different color display color? Okay. And then enumerate example meshes dot items. Where is oh yeah, over here. Mesh display color primvar mesh prim dot get display color primvar. So every time this for loop runs, a different color was set for that quad.
Yes.
Okay. Same geometry, different coloring rules. World pre-prim, one color for whole mesh. Pre-face, one color per face. Pre-vertex, one color per vertex. What does this mean? Pre-prim, pre-face, pre-vertex.
Per phase, dude. It's not pre-phase. It's per
Oh, per
phase.
face. My bad. My bad. Oh,
Just look at the
per
final
face.
view result. You will see it.
Okay, so per prim constant. This is purple, blue face, just like this. Purple, blue, red, and then gradient.
Yep.
Blue, purple, red, gradient-ish blend. Oh, always the same two square chord sharing an edge. Okay. Oh, I see. Okay, now it's going to explain. These are OpenUSD Python modules. These are OpenUSD Python modules. GF Vec3F is used both for 3D positions and RGB colors. For colors, values are usually between 0.1 and 1.0, 0.0 and 1.0. Create, okay, we know this, creates a new USD file, then creates this root prim world visual hierarchy so far slash world default prim. Okay. One node create new stage is likely helper function from your notebook course in pure USD Python. This would usually be stage dot create new. Oh, okay. Define the mesh points. So now what is this exactly? This is the color, right? Not color?
GF dot vec 3F. These are the points of the mesh, like zero, one,
Yeah,
two,
okay.
like the edges. Like we are defining a mesh. Like there can be two mesh, three mesh, four mesh.
Mesh is exactly what? Like a block, like
Yeah,
some area
yeah,
that covers on
like
a prim.
some area, and those
Okay.
are the access. Like where do your points exist for that mesh? Like edge points.
Mm-hmm.
So those are the coordinates for that.
Mm-hmm.
So here are the 6 points: y equal to 0, and then y equal to, oh, okay, okay, now it makes sense. All right, I got it. So if you look at the diagram below,
Yeah.
go, it says y equal to 1, y equal to 0, and
Mm-hmm.
now you look at the coordinates that have y equal to 0 and y equal to 1.
Mm-hmm.
You will see how they align, right?
Yeah.
Since they are aligned in a manner, it is creating a square box. If you change a coordinate, let's say you increase y 0 to 1, the coordinates are going to change, and maybe the value that is supposed to be on 0 will be somewhere else in the block. So it says y
Mm-hmm.
equal to 1 and x equal to -1. So just look at the coordinates we have in over here,
And Z
gf
is
dot.
always zero over here. Z axis is
Yeah,
always zero. Okay.
since z is always
Oh no,
0.
I got it. I got it. It's just coordinates of defining like. But why is it
Yes,
0, 1, 2, 3, 4, 5? It's why do they why are they naming it 0, 1, 2, 3, 4, 5?
they are not naming it. We are naming it.
Yeah. Okay.
Like for learning purposes. For learning purposes, like
Okay.
how will you like?
No, I got it. Okay. So the mesh has 6 points, two chord faces. 6 points and two chord faces, phase zero, phase one.
Chord is like four. So I think four indices makes one chord face.
Yeah, obviously, yeah.
Yes.
Four
So define
indices.
the faces. Oh, okay, okay. All right. So that's how we define the faces. So any vertex with that has any four vertices would be count as one face.
Yeah.
Four, four. So that's why we have like four faces, two faces.
1 second. Face vertex counts. Okay. So this could have, if it would have been a triangle, suppose
Hmm.
we
Break
would
it.
have, yeah, and we could have done like three and three.
So it would take only three. So it
Yeah.
would break. I think it will mess up something. Let's see how it looks. Do 3-3.
No, I'll
It,
I'll do the whole change next in
no,
after
do
we
it right
end.
away. We will see what happens. That's
Bro,
like
for that we'll have to change the coordinates as well over
no, it's
here.
not necessarily to change the coordinate. I don't think so. That's
Bro,
necessary.
we would
I
need to
want
because listen,
I want to see how what it does. That's why I want to break it. I want to see what the code does.
wait, I'll show you what I mean.
Do it over there, brother. Just do it.
Bro, wait.
Compilation. Just compilation. You have to change only to one line.
I know
Why
it
do you
will
want?
break. I know it will break because
No,
it's
show me. Show me. Prove me.
bro, wait.
Prove me.
If this is like if
Don't
we
want
make it
I don't want
three,
to look at Excalibur. I don't want to look at Excalibur. I
this
want to look at code. I'm not looking at Excalibur.
these are the
But
points we would need to define, man.
I want to run the code. First,
One,
freaking
yeah,
code.
wait. I'll run.
Run the freaking code.
One and
Run the freaking code.
okay.
I don't visualize if we have the code already. Just do 3-3 and I want to see the code break.
I think it did not run.
Uh, Restart kernel.
It didn't do anything, I guess.
Yeah, see, this is what I was trying to look for.
What did you understand? Tell me.
That your logic was wrong and it did not. Your freaking logic was wrong completely at this point. That it's gonna do that. Your logic was incorrect
What?
completely. Right? Oh, you know what we can do? We'll go up and change the name of the file.
Bro, no, wait. Let me understand the code first.
Change the name of the file.
What? Why?
We will see. Do. Go up. Change the name of the file to something else.
In assets.
No, no, in the file path.
Oh, this.
Yeah.
Oh,
Do.
right. Yes. Because we'll have to define a new asset file for the changes we are doing.
Mm.
Mm, what did it change? It did not change anything.
It changed. It changed the three
Oh,
the
yeah. There
page.
are 3 points now.
Yes, but for some reason the output is not getting rendered as we expect. Oh, I know why. Oh, I know why. Because of the color. Because of the color. Because of the color.
Wait. So point 3F points are 1, 2, 3, 4. And then 5. No, bro. It was 3 only.
Yeah, go back. Go back.
0, 1, 2, 3, 4. Oh, wait.
Dude, it changed, dude. Like,
Yeah,
you
it's
can
changed 3, 3, but it didn't change anything else.
like because we did not change the color. If we change the color to something else, then it might change. But it did work, right? So it did work, but the
Yeah.
output was not expected as we wanted.
Uh,
All right, let's go back to ChatGPT and then ask him.
yeah. Let's complete the code first. Okay, so we define the faces. Face vertex counts 4, 4. Phase 0 has 4 vertices. Phase 1 has 4 vertices. Phase vertex indices are this and this. Yes, we understand this. Phase 0 is 0, 1, 2, 3. Phase 1 is 1, 4, 2, 5. 1, 4, 5, 2. Phase 0, 2 faces share the middle edge. Define 3 color strategies. 1 color for whole mesh per prim color. GF vec 3F 0.5, 0.0, 0.5 R equals to Oh, so this is per prim color GF vec 3F 0.5.0.5 and then 0.5.0.5. That is purple. Okay. Whole mesh is purple. One color per face. So this is purple per face color. Oh, I get it. So when we set it per prim color and set only one RGB, it goes to both of the faces. So we are seeing one big block of purple. That's why.
Yeah.
And then we set two different colors per face
Yes.
colors. Then we define two colors. So this goes to two different faces, blue and red. And then we define some sort of gradients. Vortex colors is blue and then gradients and then this. So it starts doing this gradient shit. Blue, purple, and then red. What if I change this a little bit? Okay, I understand it till here. And then define interpolation mode and colors. ChatGPT, where you at? Okay, one color per face. There are two colors because there are two faces. Whole mesh is purple, blue, and red. One color per vertex. So, oh, so that's why per face color and per. Oh, so each vertex has its own color.
Yes.
So we are setting blue at each vertex. So it'll throw like a shade of blue from each vertex over here, and then purple from each vertex, and then red from each vertex of the ones they are defined at, and then it'll create the gradient effect. This creates color interpolation across the surface, blue, purple, red. Controls the examples. Dictionary controls the examples. This maps mesh. What is this? Prim, per face, per vertex. Oh, so this was defined. This per prim color was already defined over here. That's why they were able to use it over here. Per prim color, per face interpolation. USD geom tokens dot uniform colors equal per face colors per vertex. Interpolation USD geom dot tokens dot vertex. Interpolation mode color values. One value for whole prem is constant. One value per face is uniform. Oh, so this is USD terms, bro. This is we are going to be using this.
Yeah. Uniform, one whole value for whole prem, one value
Okay.
per point.
Mm-hmm. I see.
Interpolation. Oh, the way it's gonna render, right?
Mm-hmm.
Interpolation. Okay.
Interpolation mode, color values, constant uniform vortex. So here per prim, per face, per vortex. Per prim is constant, one color, per face is uniform, two colors, and per vortex is six colors. Actually, it was three colors, but because it was each on two vertex, so it was six colors. Okay. Loop creates three mesh prims. Now explain this. You understood this, right?
Yeah, which part?
For
Oh,
loop.
yeah, it's a basic for loop. We have the example meshes that we created over there in the above, and
Mm-hmm.
there we are trying to iterate over each and every mesh. So we are gonna
Mm-hmm.
pick up two variables. First is interpolation, and the second one is color details. So on
Mm-hmm.
each and every line, I equal to zero. So we have I over there. So that is the iteration like zero, one, two, based on the numbering sequence. So on the zeroth value, we have example mesh set as uh, per prem. That is our first JSON object that we have. Then we
Mm-hmm.
have per phase. That is the second JSON object we have, and then we have the third phase, third level. Sorry, second level. That is per vertex.
Mm-hmm.
And then once we have that, we are gonna when we are gonna pick up their values, whatever the values we have for them,
Mm-hmm.
and then we are going to append those values into our stage accordingly, like iterating again and again. So we are using mesh prim equal to usd geom dot mesh dot define api with our stage to get the path and then append the path accordingly. So we are trying to do like we are trying to put the whole block per prim and
Mm-hmm.
all the attributes we have into that mesh prim, and that's going to help us render the block accordingly. Like if you scroll down, right, you see world slash world per prim
Wait,
slash
wait, wait,
world.
wait. Can you explain this for loop for I? And
Yeah.
then they are considering example mesh and color details in to be iterated with this.
Yes. Like the
How?
JSON object we created about.
So, oh, wait. Okay. I equal to zero and then example mesh when it is per prim.
Yeah.
And color details when the color details are purple. Oh, enumerate example meshes dot items. Okay, this loops through I equal to 0, 1, 2. Example mesh per prim per face per vertex. Each iteration creates a mesh under slash world. So mesh prim equal to GSD geom dot mesh dot define stage comma world dot get path append path example mesh, which is going to be per prim, and then that would create a mesh underworld. So this will create per prim, per face, and per vertex. Correct. Hierarchy will be per prim, per face, per vertex. Okay. Give each mesh the same geometry. Mesh prim create points attribute mesh vertex locks. Face vertex counts. Face vertex indices. What does this mean? Every mesh gets the same points, face counts, face
You
indices.
create the points, the quad points, and everything, the two quad vertex and everything that we created, right? So we are
Hmm.
giving the same attributes to our prims so that they can be identical to each other. And then we are gonna move the mesh sideways using the xform common API, and then providing the translate value.
Hmm.
Go down.
So all three meshes are geometrically identical. Okay, USD Geom. Bro, this is fucking tough. Primvares is.
It's not tough, dude. It's basically simple code.
Yeah, it's simple code, yeah, but it's very complex.
Like, dude, it's not complex. It's the understanding is complex. Like once we get started, we are gonna use anyways cloud code.
Yeah, I know. For the certification, cloud code is not gonna come there, bro.
No, but by the time we are done with this, because we would be able to solve it pretty easily. I don't think it's gonna be that tough because it's all
Mm-hmm.
about just knowing the API and what it is trying to do.
Mm-hmm. What about the syntax?
Yeah, we will get to know the syntax as we go through the code base. That's what I'm saying.
Mm-hmm. I see.
Like initially when we started with the default prim and all those things, it was we thought that was tough,
Mm-hmm.
but it became easier.
Mm-hmm.
If you look at the translate thing, like the last line, that was pretty straightforward,
Mm-hmm.
where we are trying to use the XFORM common API and then
Mm-hmm.
enclose our and then do some kind of translation. That is a XFORM operation.
Mm-hmm.
That just to know that okay, and then we are trying to use the same I into 2.5 comma 0 comma 0 to
Mm-hmm.
render the blocks next to each other. That's an X axis. So since we are looking at this first time, it's looking difficult, but I don't think it's that difficult.
Mm-hmm. So give each mesh the same geometry. I think we'll just do primvars, bro, today.
Yeah,
It's
yeah,
very long.
yeah. Primavera is mostly code.
Yeah. Okay. Let's see what. Okay. Example. So, okay, I understand this. Now, this loops through this. Example mesh is defining the color and the interpolation. Uniform, constant, and vertex. So this is three types of interpolation is vertex, uniform, and constant.
Yeah. And interpolation means how a primware data is attached to a mesh. That is the most important thing over here. Like
Interpolation is how
how we are attaching
data.
primware data, variable
Uh,
data
uh-huh.
to a mesh. To
Uh-huh.
a mesh.
Okay.
So we go up, the interpolation was first vertex,
Mm-hmm.
then the surface, and then by uniform, then uniform. So that's the most important thing over here.
Okay. So we have this. Oh, nice. Look at this. Python script, import, create world, set world, define mesh geometry, 6 points, two faces, face vertex, indices, define color arrays, per prim color is one purple color, per face is blue red, per vertex is six colors, build example mesh directory, loop over three examples, world per prim, per face, per vertex meshes. Apply same mesh geometry, move mesh sideways. What is this? X equals to
Sideways, XFORM transformation, brother. XFORM
oh
transformation
transform X form. Okay, okay.
on the x-axis.
X equal to I into 2.5. So it's moving sideways. Get display color primware, set interpolation mode, set color values, more examples. No save USD stage. I see. This is the for loop.
Yeah,
So first for loop they'll go over here, and then second will here, and then third will here. Got it. Yeah, I think Okay, we can go to the next example. Oof. Second example. Set the rest state for the mesh.
And deformation as prim was. So this example writes two vertex prims on a quad, rest state and deformation. It computes new point as rest state plus deformation and then time samples mesh points. Oh, I see. Rest state. What is rest state, first of all? So we are trying to define our time sampling parameters initially. That is, what is a time count? That is one, and the time count is 90, and
Mm-hmm.
the time code over here is 30. So we create staged and default prim file path assets. Okay, that's simple. That's simple. And then we have this mesh that we have created one, two, three, four. So it's gonna be two on x-axis. Okay, it's a square basically. Two on x-axis, two on y-axis. So one, one, and one, one. Yeah, it's a square. And
Setting up
then
one second. Set up time sampling parameters. Start TC, end TC, time code per second. Oh, this is the time sampling thing that we did.
what the fuck I did just said right now? Did I say something else, motherfucker? Did I say
I
something
zoned out.
of shit?
Mm-hmm.
We are defining the mesh. So it's a square mesh based on that. And then we
Mm-hmm.
have phase vertex indices 0, 1, 2, 3. Since we have 4, 1, 2, 3, 4. Then we have create mesh prim.
Mm-hmm.
So create, now this is the most important part. Like this is where the important part starts. We have created our mesh prim. Then we are gonna assign our attributes, the face vertex count, the face vertex indices, the necessary things we did in our last code snippet, and then we are gonna give it some kind of translation that is along x-axis using XCOM common API. And on line 32, we are trying to display the color of that, right? So it's gonna be point 0.1, point 0.8, point 0.1. So I think it's green based on
Mm-hmm.
the output. And now let's focus on the rest state for the mesh. So we are now creating a primvar API, primvar variable using the primvars API, and wrapping our mesh prim into it.
Mm-hmm.
Once we have created that, we are using create primvar to create our basically the basic lambda function that I told we are trying to create over here, and we are going to
Mm-hmm.
name it rest underscore state, and the type value it has is sgf dot value type dot float 3 array. So it's a float 3D array, I would say, like three-dimensional array. And then we are gonna use usd geom dot tokens dot vertex to like distribute it over the vertices, and then set it over our mesh vertex locks. That is our edge vertex that we defined earlier. So this is how we have defined our rest state in plain prior API primware that we just created. So our rest state has a floating 3D array, and the tokens is a dot vertex. Like the distribution is over the vertex, and we are setting it over the mesh vertex locks that we created over there.
Mm-hmm.
Now let's focus on the deformation. So deformation follows one, two, three, four.
Where
So
are you reading? What line are you reading?
what to do?
42? Okay.
Yeah.
Uh-huh.
So I think this is trying to create the deformation. So if we just look at the output below, we will see what kind of deformation it wanted. That is in this manner. And once we have that, we are gonna again wrap our plane into a new. Wait, why are we wrapping it again? I'm confused now. We are wrapping it two times. Okay, so we do have to wrap it two times. This is confusing. Like we are wrapping, like you, if you look at line 48 and line 35, both of them are same.
So one second, let me go back a little bit. We are defining base mesh at 0, 1,
It's a
1
four
comma 1, and
square. It's
then
a
yeah, it's a square. Face
square.
vertex, then only 4, and then vertex
Yeah.
indices are okay. So this is basically a square, and then create mesh prim plane equal to USD geom dot mesh dot define stage world dot get path plane. And so this is under slash world slash plane, and then plane dot create points attribute mesh vertex locks. So point attributes, these point attributes are created as meshes, or these vertices are created as mesh on the plane,
Uh,
and then plane dot create face vertex counters counts attribute. What does this line do? 29?
it creates the point. It creates the face vertex point attribute, brother. Face vertex, like
Oh,
you have to define each and every attribute. So that's how you define. Like you are giving your edges some kind of value. Like what is it gonna pick it up in the mesh? So that's
okay.
how you define them.
Face vertex indices, face vertex count. So this is all plain create mesh prim. Okay, so the mesh prim is given these metrics or this data to call when they need to work with that square.
Yeah, yeah,
Exactly right.
yeah.
And then USD geom.xform API plane set trans. So this is rotating it. This is translating it at x axis, and then get display color primvar dot set, and then this is giving it the green color that it needs, RBG.
Mm-hmm.
And now set the rest state for the mesh. So plain primvar API equals to primvar dot USD dot primvar API plain. So this is setting the plain primvar API, just like we did above, right? This is
Yeah.
plain primvar. What?
Yeah.
Plain primvar API equal to USD geom dot primvar API plain. So this is setting the plain prim as an API in the plain primvar API, and then we are creating a rest state using that plain, right?
Mm-hmm.
And then uh, plain primvar API dot create primvar rest state SDF value type name float 3 array, and then USD geom dot tokens vertex dot set mesh vertex logs. Okay, now I don't know what float 3 array is doing over here. SDF dot value type name float 3 array, and
Float array.
what?
Similar to 3D float array, like three-dimensional float. So like the values will have
Oh
3.0,
yeah, okay, okay, okay.
5.0, like that.
Floating point operations.
Yes.
Okay. USD geom dot tokens dot what is this? Like why is it in a what is this? USD geom dot tokens dot vertex? What is this doing?
But I think it's defining where will those points be applied, like when the rest state is implied onto that prim, where will the effects take place. So in our above code base, we have vertex, uniform,
Okay,
and
let it be. We'll understand this later in ChatGPT. But okay, so it is setting the rest state for the mesh, which it created using the plane Prevar API, which was created using this plane,
mm-hmm,
which was in turn created using the square on the axis.
mm-hmm.
And then set deformation for vertex locations as primvar deformation. So okay, now it's creating some sort of deformation. What do you say? The thing,
Mesh, deformation mesh.
mesh. No, the structure, bro. Like,
Well, yeah, yeah.
0 0 0 0 minus point 0.3 minus point 3.40. So this is like some sort of, what do you say in
Deformed mesh, like that's what it would mean over here.
wait, graph point maker, plotter or plot points, no maker. Uh, so
Einstein,
let,
Einstein, I'm looking at it. Dude, that's a 2D graph and that's a four-dimensional
but we
deformation.
don't need z-axis, bro. We don't need z-axis because it's anyway
But
zero.
how would you define the other four coordinates? Just four coordinates. You only have two coordinates over there.
Bro, we can add four coordinates
So,
as
so
many
what
as
I'm saying. But if you look it down, that's what it is trying to do over there. Like just look at the output.
I know, bro. And I'm just so that we just,
What
bro,
you know, it's gonna be the
shut the
same.
fuck up. 1 second. I know it's gonna be the same. That's why I'm doing it. I'm just trying to get it clarified. Like, the shape.
It's gonna be something different. You're saying.
It's not gonna be something different. I'm saying it's gonna.
Right? Like earlier, ChatGPT told you, so it's gonna be on negative side. So two of the coordinates, and so two of the coordinates are gonna be on the positive side with the y-axis going up.
I wanna do it. I'm just
Yeah,
curious.
yeah, do. I'm looking at it.
Minus. So you see, these 2 points are exactly same.
Yeah. Oh my God.
So this is a deformation now. Okay. So it's not the same. You see, bro. We
Mm.
understand now. This is something different, and this is something different. This is not the deformation. So what's happening over here is they added this coordinate for deformation, and then plain Prevar API USD geom Prevar API plain. What? Why are they doing it again? They did it
Yeah.
once, right?
That's the question that was that I had the same question. I don't know. For some reason, they are doing it again.
Plain. Okay. I think they need to do it every time they create a new mesh, I
I don't
guess,
know.
because here they are creating the
No, no.
rest state,
Why would you want to create a new mesh? You are not creating a new mesh.
and then they are creating the deformation one over here, and then
That is like some kind of definition. It should not be like, I think either it's a bug or something like, or we can ask Chat GPT.
oh, create new
I
issue.
don't, I don't think so. Like it would matter creating or defining it again and again.
Hmm.
Because you're basically wrapping the same prim, and you are not even renaming the new primware that we are trying to create over here.
let me do one thing. Let me plot this once and see if they are giving the same. Ba 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 bum bum. Ba bum 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 bum.
So for oh, okay, 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 okay. All right, all right. Now it makes sense. Now it makes sense what they're trying to do over there, and then why they're trying to use deformation. So we have new points
Yeah,
based on the
I think
deformation.
the deformation.
Like if you look at the line 54 and 57, you will see what they're trying to do.
Okay, so see, this is the new thing that they get plotted.
Hmm.
Why are we not? Why is there no?
No, but I get it. I get it.
Yeah, so this is the new shape.
Go back over there and look at the line 54 and 57.
New points are P plus 0 for P
Oh,
0 in zip.
it's P plus O, not
Oh, P
zero.
plus O, sorry. P plus O. Mesh vertex locks, plain prevar API, get primvar deformation dot get. Some crazy ass.
In zip. So, based on my understanding,
Hmm.
from line 49 to 52,
Hmm.
we created a primvar
Uh-huh.
named deformation and then gave it a value type that is SDF dot value type name dot
Float
float,
3 area.
and then we are defining it as USD geom dot token dot vertex for the distribution, like that interpolation, and we set the deformation, the whatever the value we created over there, right?
Mm-hmm.
For the first state, we kept mesh underscore vertex underscore locks, but for the next primware, we created set deformation. Like we use set deformation to set the deformation attributes. You know what I'm saying,
Mm-hmm.
right? And then once we did that, we are trying to create new points.
Mm-hmm.
And to create new points, we are basically getting the value plain primvar underscore API dot get primvar based on the name we use to create the primvar variable or the primvar that was deformation.
Wait. What did you say?
So
We.
if you look at line 57,
Mm-hmm.
plain primvar underscore API dot primvar
Mm-hmm.
deformation.
Mm-hmm.
This was something that we created on line 49,
Yeah.
right? And then we are trying to call the attribute by using dot get.
Yeah.
So once we have that, we are basically adding the values over there. So P, so we are adding each and every point P plus O. So P is the point 0 over here for the mesh vertex locks. Like if you go up,
Mm-hmm.
so first value is 0 for the first
Yeah.
array,
Yeah.
and then that will be the first point, and then we will add O. O, what would be O? O would be
Bro, wait. I think it's time. Give it to ChatGPT. It's getting too complex. The loop is heart of the script. Primvar. Batman. This code creates one square plane, stores the custom per vertex deformation vector, calculates new vertex position, then animates the mesh from its original shape to the deformed shape over 90 time codes. Oh, I think what this code is basically showing us is how the animation will happen. I
Yes.
think. I think. Like if
Yes.
you remember we did that code for bouncing ball.
Yeah, 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 yeah.
I think this is
No,
so the
this is what it is, but it's not doing it right away for some reason. Like they in the code, it should like do the deformation over here, but it is not. But if we go in our notebook, it should do. Just
uh
run our notebook and we might be able to see the deformation
no, I
happening.
think oh, like the animation.
Yeah, the animation.
I don't think so, but
Yeah.
it's just a static image. Yeah, nothing.
Mm. Okay, maybe we are just printing the deformed image, but it should. It says over here that plain point, plain dot get point attribute, plain points dot set mesh vertex locks USD dot time code start TC plain points dot set new points USD dot time code NTC like the line 65 and 66.
Mm-hmm.
I don't know. Like I thought that was supposed to do that.
Plain. Okay, we let's see at the USD file that gets generated from that code. So world plain, right? This is default premise world. End time code is okay. We are just doing the time sample thing. Int face vertex count. So this is the usual square indices points. One time sample. Oh, did we define the one time sample? I think I understand. Oh, I understand. I get it. Hmm. Set animation timeline 1 to 90. Define square mesh point. Color plain green. Store original points in primarial state. Store movement offset and primvar deformation. Compute new points. Original point plus deformation offset. Time sample mesh dot points. Add framework original square at 90. Okay, okay. I understand the code completely now. I think.
Mm-hmm.
Do you want to do the quiz now?
Yeah, sure.
I mean, there is not too much to do for the quiz because we only did two like blocks of code.
But that was really complex. So like
It
maybe
was complex.
we can do the quiz tomorrow with the value resolution and the custom properties once we do that. But can you ask ChatGPT why isn't it rendering like doing the bounce animation or anything? Just ask ChatGPT why is the code not doing any animation?
It should show the deformation happening in real time.
Yeah.
Oh, oh, we are just able to view it at the particular time sample, not but running the script as usual, blah blah blah. Do you want me to uh, show you the animation? I
Yeah,
can
I want to
show.
see the animation. Why are we not able to do the animation? Like, what are we missing in the code? I want to understand because I do want to see the rest state animation and the other animation that we are doing.
Let's see if it does it. I think.
What happened?
One second, I think we should be able to view this. Ah, yes. Look at this. Now you're ready for the time
Yes.
sample. Look at the oh deformation.
AI. So like we have to do it in
We have to
control.
do it in USD view, like the viewer,
Oh, okay, okay. So we
because
cannot
yeah,
do it end to
because we can do the thing frame by
end.
frame.
Oh, okay, okay, okay. Makes sense. Makes sense.
Deformation.
Perfect.
Yeah, boy, crazy.
Nice.
Fuck are they doing, bro? What the fuck? Okay. Okay, so it is not that complex. I understand it now.
Yeah, it's not that complex, but like as we go through
Yeah.
more iterations and we will get to know more about the code base, it's gonna get much
Oh,
easier.
somebody in the chat said, wow.
See, getting the traction, getting the traction. That's
Hell
why I told you.
yeah.
Thanks, brother.
Madhav Chanda I4N. We appreciate it. It keeps us
Yes.
going. Okay. We can read a little bit about value resolution. We can do the quiz tomorrow
Okay.
because yeah, we should I think we should do value resolution as well. It's not too
Mm-hmm.
big. I think it is big, but
Dude,
it
if it is
can
big, then wait. If it is big, yeah, dude, it's way too big. Way too big. Oh, damn.
damn.
What we can do is we will just do the introduction and then we will stop. That will just give us enough
Mm-hmm.
runway for tomorrow, like so that we will have to only do a recap.
Okay. Combines multiple data pieces to produce a single value. Differs from composition, which caches layer indexing when a stage is open, or what the value resolution. Value resolution is how OpenUSD figures out the final value of a property or a piece of metadata by looking at all the different sources that might have information about it. Think of it as like solving a puzzle where you have multiple pieces of information from the different places and you need to figure out what the final answer should be. Even though value resolution combines many pieces of data together, it's different from composition understanding. It's this difference helps you work with USD more effectively. Key difference between composition and value resolution. Composition is cached. Okay, combining multiple layers. Create final compose scene. Composition is cached, value resolution is not. When you open the stage or add new scene data, USD creates an index of the composition logic and result at the prim level for quick access. However, USD doesn't pre-calculate the final value um, of properties. This keeps the system fast and uses less memory. Whew. I think we'll have to go through the whole notebook or the whole modules again after we complete them.
Yeah,
In
yeah,
like a,
that will. So we will do a what I say. We should do a mega quiz on weekend to just do a complete recap of
mm-hmm,
what we have learned till now. So
mm-hmm,
and just, like a refreshment on our basics and everything.
mm-hmm. I see.
So
Oh,
value distribution is how OpenUSD figures out the final value of a property or a piece
mm-hmm.
of material. Shit, my camera. Bullshit. I don't know.
What happened?
For some reason, my camera goes out of focus all the freaking time. See again. It's out of. No, it's back. All right, perfect. So value resolution is how OpenUSD figures out the final value of a property or a piece of metadata by looking at all different sources that might have information about it. Think of it as it like solving a puzzle where you have multiple pieces of information from different places and you need to figure out what the final answer would be. Even though value resolution combines many pieces of data together, it's different from composition. Understanding this difference helps you work with USD more effectively. I see, I see. Let's say like basically it's a property or something, and we are just gonna pick up the final value of our property or metadata. That is the only thing.
Mm-hmm.
Animates recently added, blah blah blah. Dude, dude, this is like really some complex shit. It's gonna take time.
The key difference between composition, value, resolution, data type.
Uh,
It's not that complex. Value resolution,
Okay, when you
strong.
open a page or add new scene data, USD creates an index of the composition logic and result at the prim level for quick access. However, USD doesn't pre-calculate the final value of property. This keeps the system fast and uses less memory. Mm. Oh, oh, okay, 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 okay. So it's something related to how values are getting computed.
Mm-hmm.
If you need to get the same attribute value many times, you can use special tools like use attribute carry query to cache this information yourself. Now, composition rules vary by composition arc. Value resolution rules vary by data type. Important thing. So for value resolution, the rules are going to vary by data type. Whereas for composition, it's going to vary by composition arc that we discussed in
Mm-hmm.
our last stream. Composition figures out where all data comes from and creates an index of sources for each prim. Value resolution then takes this ordered list from strongest to weakest and combine the opinion data
Bro, we
according to
can do
what
this tomorrow. This is a
okay,
lot.
yeah, I know it is a lot, but I was just trying to get the gist of
Yeah, I got the gist. I know what it is doing. It's like three
what
different
is
types
it.
of.
What is the gist?
The
Tell it.
gist is basically we are defining some sort of mechanism to fetch the correct attributes for, the
You,
resolution
brother, compute. We are computing the
compute.
final
Yeah.
values. We are trying to compute the final values, and those values will depend. Those compute will depend based upon the data
Yeah,
type.
high LOD, low LOD, that sort uh,
Yes,
yeah.
sir. Oh, resolving metadata, dude. Everything is gonna all come together. Okay, we have the metadata relationships and attributes over there as well. Code base looks like okay. Time code, dude. I need to do a recap on time code for some reason. I'm not able to like
Bro, it's
get
so
it.
easy. Start TC is the first frame, end TC is the last frame. Cube
Yeah.
animate start TC is 60. And then I don't know what mid T is, but time code per second is 30.
So easy, brother. Now you don't know what mitti is, you piece of shit, brother. Fuck
What
you.
is mid T? I don't know. They have just defined a.
Mid time. That is basically doing the cube animation start time plus end time divided by two.
Okay.
We defined that's
Oh,
such
this is
a
the
long.
middle frame. Middle frame. Cube animation start time. Okay. So, time code per second. God damn. Custom properties is very big as well. Active and
I
active
think
pin.
things keep getting bigger and bigger, but each day, day one.
Oof, some complex shit going on over here. Model kinds. Stage traversal. Hydra. OpenUSD. Oh my god, units in OpenUSD are insane.
Damn. I'm saying, dude, it's gonna get more interesting and interesting.
Yeah. Oh. Oh, bro, it's gonna be insane. Oh, we don't even need to create a project. They're gonna help us, like guide us do all these exercises.
Makes sense.
So once we keep doing them, I think we're gonna. Oh, holy shit. I think we need to do like a marathon for the stream. Not today, but I think we'll need bigger streams now, like 3, 4 hours.
Yeah, that's fine.
We should aim 4 hours every day now.
For sure. 4 hours every day.
I think we should do it, bro.
Stop sleeping.
Stop sleeping, stop eating,
All
stop
right, perfect.
living.
Perfect. Best life ever.
Best life ever. Like we need to put in 70 to 80 work hours, bro, every week.
Starting a company is like eating glass, raw glass, or staring
Yeah.
into abyss.
But
We don't work.
then, but then after a while, you become all you're gonna be one of the first trillionaires.
Yes, Elon Musk again strikes. Trillionaire motherfucker. SpaceX IPO is coming on 22nd of June, I guess. And that motherfucker is gonna be a trillionaire soon.
A trillionaire.
Because
Damn.
Anthropic is already paying them like $12 billion for their GPU centers.
Hmm. VC money. Nice. Okay, I think we can end the stream for today.
All right.
10:45. 1 hour 43 minutes. All right. Ciao. 50 views.
Yes, nice.